Skill 8. Expanding using FOIL. When we're multiplying two sets of brackets together, we use what's called FOIL. This is broken down into 4 steps, which you can see over on the right hand side. The F stands for first, so we're multiplying the first term in each set of brackets. If we use 7a as an example, we've got a plus 2 and a plus 3. So we're multiplying these brackets together. If we multiply the first term in each bracket, that's a times a. A times a gives a squared. Then we multiply the outer terms, so the ones on the outside. This would be a times 3. A times 3 gives 3a. The third step is the inners. So now we're starting with the 2. 2 times a gives 2a. And then we've got the last. So the last term in each bracket, which is the 2 times the 3. 2 times 3 is 6. Now we've got 4 terms because we had to do 4 steps of multiplication. Before we finish, we need to check if there are any like terms. We've got an a squared and there's no other a squareds, so we can put that in our final answer. We've got a 3a and a 2a. These are like terms, so we can group them and work them out. 3a plus 2a gives 5a. And then the last term is just a number. We call that a constant. So we put that on the end because there's no other numbers. And that's plus 6. So our final answer is a squared plus 5a plus 6. 4 steps. If we look at the next one, we've got 2a plus 3 and a plus 2. The first terms, 2a times a is 2a squared. The outer terms are 2a times 2 gives 4a. Then we've got the inners, 3 times a gives 3a. And then we've got the last, 3 times 2 gives 6. Again, we look for any like terms. There's only one a squared term, that's 2a squared. The middle ones are like terms. This time it's 4 plus 3, so that gives 7a. And the last term is again a number, so we put that on the end, plus 6. 2a squared plus 7a plus 6 is the final answer. 3 more examples. 9a. We've got x plus y, z plus 1. So here we've got more letters and only one number. Z times x is z. Oh, sorry, x times z is xz. Then we've got x times 1, which is just x. Then we've got y times z is yz. And finally, y times 1, which is y. Have we got any like terms? Doesn't look like it. xz is different from yz. X by itself, there's nothing like that, and there's nothing like y by itself. So this would just be our final answer here. We would have to leave that how it is because there's no like terms. D, we've got 3p plus q, and the other bracket is r plus 1. 3p times r is 3pr. You can put the letters in any order, but generally try and go for alphabetical order. The next terms are 3p times 1, simply 3p. Then the inners, q times r, is qr. And the last Q times 1 gives Q. Have we got any like terms? No, we don't. They're similar, they look pretty close, but none of them are like terms. None of them have exactly the same letters to the same powers. So that's our final answer there. The last one, G, is x plus y, 2x take 3y. The first, x times 2x, is 2x squared. The outers, x times negative 3y will give negative 3xy. The inners, y times 2x is positive 2xy. And the last, y times negative 3y is negative 3y squared, because they've both got y in them. Let's look for like terms. There's no other x squared, so we'll put 2x squared in. There's two terms with xy. So let's look at the numbers out the front. Negative 3 plus 2 would give negative 1 xy. And then our last term is negative 3y squared. Before we write this as our final answer, remember we don't have negative 1 out the front. So let's write it again. 2x squared, take xy, take 3y squared. That's our final answer.